So today we're going to go over rewriting an expression from exponential to log, and then we're going to go back from log to exponential. So we're going to start with an exponential expression, and the exponent is always going to stay on the side that the exponent was written. So 3 is going to stay on the side that it was written, and then log for logarithm, and the base of the log is always going to match the base of the exponential expression. So it's going to be log base 2 of 8. And that's how you read that. So you read that 3 is equal to log base 2 of 8. And so sometimes we'll put the of part in parentheses, but you don't really need to. So let's do the next one. So the exponent goes on the side that the exponent was written. So 2 is equal to log base, and whatever the base is of the exponential is always going to be the base of the log. So this is going to be log base 4 of 16. So it's 2 is equal to log base 4 of 16, right? So 2 is equal to log base 4 of 16. And that's how you'd read that. So let's do the next one. So to rewrite it as a log expression, whatever is the exponent should stay on the same side. So we're going to write y plus 2 is equal to log base, and since this base is 5, that's going to be the base of the exponent. So log base 5 of x, right? So y, so this is going to be copied down. So log base 5 of x is equal to y plus 2. So y plus 2 is equal to log base 5 of x. So I could put this in green so you can follow the colors. So that what it's equal to is the of part. What it's equal to is the of part, right? So we're going to write this one as 3 to the x, because whatever the exponent is should stay on the side that the exponent is. So 3x is equal to, now if the base is e, we don't write log base e, right? You could, but base e is an irrational number, approximately 2.718, and it's used a lot, we see it a lot in the natural world. So we just write ln for natural log, and then we don't have to write the e. So we can drop the e if we write log. So we write the natural log of y, because this is really a hidden e. So the natural log of e, so 3x is equal to the natural log base e of y. We can drop the e and just say 3x is equal to the natural log of y. So remember, the base is always the base of the exponent. So that technically is log base e. But when it's a natural log, we just use ln and we drop the log. And then base 10, so the exponent stays on the side that the exponent is written. So negative 2 log base 10 of 0.01. So log base 10 of 0.01. And when you have a base 10, that is called a common log. And base 10 logs are used a lot as well. So we all agree in the mathematical community that if there is no base, it's assumed it's a 10, and that is a common log. So if you don't see a base, it's a common log, and that means it's base 10. So we would read this as negative 2 equals the common log of 0.01. So let's try going the other direction, and then rewriting it from exponential to log. Have a good day. So now we're going the other direction. We're going from a logarithmic or log to exponential. So take the log expression and rewrite it in exponential form. So when we do this, the of part is going to be written on the side that the of part is written. So we're going to write 9 is equal to, and then whatever the base is has to be the base of the exponent, and what it's equal to is, so it's 3 squared. So 9 is equal to, I guess I should make my colors. So 9 is equal to 3 squared. So the of part stays on the side that the of part was written. So x plus 1 is equal to 4 to the 5th power. So 4 to the 5th power. So x plus 1 is equal to 4 to the 5th power. And that's it. So this is going to be 2x is equal to, now notice there is no base. There's no base written right there. So that means this is a common log. And if it's a common log, that means the base is really 10. So it's 10 to the 4th power. So when there is no base, that means the base is 10, and that's called a common log. And it's being raised to the 4th power. When it's ln, like in this one, it's ln. So x is equal to, and so it's ln. So ln is a natural log. And that could have been written as log base e of x equals 4. But we write it as short. We write it like this for short. Right? So that means the base really is an e. So it's e to the 4th power is how you'd write that one. So again, you write the of part on the side that the of part is written. So 1/8 is equal to 2 to the negative 3rd power. So 2 to the negative 3rd power. That's a true statement, isn't it? So whatever is the of part of the log, or the inside the log is, that should stay on the side that it was written. And then it's going to be y is equal to 3 to the x plus 1 power. So 3 to the x plus 1 power. 3 to the x plus 1 power. And then if you want, you can rewrite it. If you wanted to, you could rewrite it. Okay, so let's look at some properties now. Last slide. You got rewriting it from a log to an exponential. So there are some properties that we technically should already know, right? So if you were trying to think of what this means, remember we did what powers? So aren't we saying 1 can be written as 4 to the what power? So obviously, wouldn't that have to be 0? So it doesn't really matter what base you have. If the of part is 1, wouldn't that always have to be 0 no matter what? So log base 6 of 1, wouldn't that have to be 0? Because isn't 1 equal 6 to the 0? Isn't 1 equal to 5 to the 0? So isn't that a true statement regardless of what the base is? So technically, you don't have to memorize these because you can just figure them out yourself. But it's just kind of good to know, right? So you're saying 5 could be equal to 5 to the what power? So wouldn't this have to be 1? So regardless if it was log base 6 of 6 would have to be 1. Log base 7 of 7 would have to be 1. Because isn't 7 equal to 7 to the 1st power? Isn't 6 equal to 6 to the 1st power? So that makes sense. And notice how these are reciprocals of each other. So the base is 6, but the of part is the reciprocal of 6. So when the base and the of part are reciprocals of each other, it would be -1. And again, if you don't have to memorize that, because you can just say 1/6 is equal to 6 to the what power? And wouldn't that have to equal a -1 to make that a true sentence? So if we had log base 2/3 to the 3/2 power, that would have to write 3/2 could be written as 2/3 to the what power? Well, wouldn't it have to be -1 to make that a true story? Right? And notice that these are reciprocals. So it's always going to equal -1. But again, don't have to memorize them, just know. So on this one, when you have an of part that is 0, it is undefined. And when you have a negative number, it is undefined. 0 can be written as 7 to the what power? Nothing. That's why that's undefined. So regardless what the base is, log base 7 of 0 is how you read that. Log base 7 of 0 is undefined. For number 5, you read that log base 3 of negative 27 is how you read that. So negative 27 can be written as 3 to the what power? Nothing, because if you put 3 to the negative 3, that makes it 1 over 3 cubed, which is 1 over 27. So that's not true. So that's undefined. So those are ones that we should start to know and understand when we have undefined situations. And then we have inverse properties. This first inverse property says, if you have a base and up in the exponent, you have a log up in the exponent that happens to have the same base in the log as the base in the exponential, your answer will always equal whatever is in the of part of the log, right? So here we have an example. We have something written with 7 to the, and up is a log that has the same base, right? So we have a base, and then we have an exponential up in the exponent with the same base. Therefore, our answer is just going to be 2x. On example number 2, remember ln is natural log. So you would read that e to the natural log of 3 is how you'd read that. E to the natural log of 3. So remember, natural log of 3 means that really is e. And since those are the same, the property says that our answer is just going to be 3. Right? And then example 3 is 10 to the common log of 4. 10 to the common log of 4. And if you have no base, that implies the base is 10. So that would equal 4 because the bases of the log and the exponential are the same. So that's how that property, inverse property, works. Then there's this last inverse property. This property says that if you have a log that has a base and in the of part, the base matches, then whatever the exponent of the inside is going to be the answer. So notice how you have log base 3 of 3 to the 4x power. That's how you'd read it. Log base 3 of 3 to the 4x power. Well, since those bases are the same, that means our answer is going to be 4x. So since this base and this base are the same, our answer is just going to be 6. Right? This is number 3 would be the natural log of e to the 5th power. The natural log of e to the 5th power. So remember, natural log means, so we really could have written this as log base e of e to the 5th power. But we don't want you, when you have base e, we don't want you to use the log notation. We want you to use the ln notation for natural log. And we use ln that way. You can write ln that way. We tend to write ln that way or that way, either way. And that means the base is e. So you have to know that that means the base is e and those are the same. So the answer is just going to be 5. And then this one, the bases are not the same, right? So the property does not apply unless I can get this to have the same base. So could I rewrite that? So log base 2 of, could I rewrite 8 as 2 to the 3rd power and then to the x? And isn't that a power? So that could be rewritten as log base 2 of 2 to the 3x. now that the bases are the same, the answer is just going to be 3x. So if you can get it to the base, if you can get the bases to be the same, then it would just equal 3x, right? This is the common log of 10 to the 5x power. Common log of 10 to the 5x power. So remember, if there's no base, that implies the base is 10. So we do have where the bases are the same, so the answer is just going to be 5x. And those are the inverse properties. So inverse properties and how those work. Some basic properties that you should know. And you got your inverse properties.